What on earth could a lemon, a bar of soap, and a bee sting possibly have in common? Well, the answer is this incredible, hidden world of chemistry that's happening all around us all the time, from our kitchens to deep inside our own bodies. Today, we're pulling back the curtain on the secrets of acids and bases.
So let's really think about this. What actually connects the sharp, sour pucker of a lemon with the, slippery feel of soap and that feeling of relief you get from an antacid tablet? They seem like they're from completely different worlds, but believe it or not, they are all part of the very same chemical story.
And here's the secret. They're all either acids or bases. Acids are the reason lemons and vinegar have that sour kick. Bases, on the other hand, are often bitter and feel kind of soapy or slippery, just like baking soda or a bar of soap. They're basically chemical opposites, hiding in plain sight. And the best place to see these chemical opposites go head-to-head is somewhere you might not expect: your kitchen.
This brings us to a really key idea: neutralization. It's exactly what's happening when you take an antacid for heartburn. See, your stomach produces a really strong acid, but sometimes it just makes too much. An antacid is a mild base, and when it meets all that extra acid, it neutralizes it. They cancel each other out, creating simple salt and water. It's a perfect chemical truce happening right inside your body.
Okay, so we know what they might taste or feel like, but let's be real. Tasting random chemicals is a terrible idea. So how do we identify them safely? Well, it turns out acids and bases can't really hide their true colors.
We use something called a chemical indicator. And you can think of it like a little chemical detective. It's a special substance that'll change its color, or sometimes even its smell, to signal whether it's found an acid or a base.
And these indicators are everywhere. Some are totally natural, like litmus. Maybe you remember litmus paper from school. It turns red in an acid and blue in a base. And then there are synthetic ones, made in a lab, like phenolphthalein, which makes this dramatic switch from completely colorless to a brilliant pink the second it detects a base. Here's a real-world example I bet you've seen. Ever get a curry stain on a white shirt? Well, the turmeric that gives curry its color is a natural indicator. So when you go to wash it with soap, which is a base, that bright yellow stain suddenly turns a deep reddish brown. That's a chemical indicator at work, right in your laundry basket.
All right, so now we know how to spot them. But what can they actually do? Well, let's get into some of their most interesting reactions.
One of the classic moves of an acid is how it reacts with metals. When an acid touches most common metals, it starts to eat away at it, creating two things in the process: a salt and a very specific, very flammable gas. That gas is hydrogen, and chemists have a really simple and, honestly, a pretty cool way to prove it. You just collect the gas bubbling off the reaction, and then you bring a flame, like from a burning candle, right up to the mouth of the test tube. And if it's hydrogen gas, you hear this awesome, unmistakable pop sound as the gas ignites. It's like a tiny, controlled explosion, and it's the definitive signature of hydrogen. So, next time you think about acid and metal, just imagine that little pop. Acids also have a really dramatic reaction with another type of substance called carbonates. Think of things like chalk or marble. This reaction pumps out carbon dioxide gas, which you see as all that vigorous fizzing and bubbling. We have a word for that: effervescence.
So wait a minute. Some acids are safe enough to have in our salad dressing, while others can literally dissolve metal. What gives? Well, it all comes down to their strength, and to measure that, scientists use something called the pH scale. This is the pH scale. It's a simple range from 0 to 14 that tells us exactly how acidic or basic something is by measuring hydrogen ions. And here's a fun fact for you. The P in pH actually comes from the German word Potenz, which means power. So pH is literally the power of hydrogen. How cool is that? And it's super easy to read. Anything with a pH less than 7 is an acid, and the lower the number, the stronger the acid. So something like battery acid would be way down close to 0. Right in the middle, you've got a pH of exactly 7. This is perfectly neutral, not acidic, not basic. The classic example here is pure water. It's the perfect balance point.
And you guessed it, anything with a pH above 7 is a base, which we also call alkaline. The strength increases as you go up, all the way to 14, where you'd find super strong bases like drain cleaner.
But here's a really important distinction. In chemistry, strong doesn't always mean dangerous. It's really about how completely an acid or base breaks apart, or ionizes, in water. A strong acid, like the hydrochloric acid in our stomachs, is like a floodlight. It releases all of its power at once.
A weak acid, like the acetic acid in vinegar, is more like a dimmer switch. It only releases a little bit of its power, which is exactly why we can eat it.
So this is all cool chemistry, but why does any of it really matter? Well, it turns out this chemical balancing act is absolutely critical to, well, almost everything, from our own survival to huge industrial processes that run the world. Just look at this stuff. Our bodies have to stay in this tiny, precise pH window just to stay alive. When rain's pH drops too low, we get acid rain, which can devastate entire ecosystems. Even your teeth start decaying if the pH in your mouth dips just a little below 5.5. And that bee sting? It's an acidic injection. That's why a mild base like baking soda helps soothe it. It's neutralization in action.
And on a massive scale, this chemistry is a total powerhouse. Take the chloralkali process. It sounds complex, but it's kind of like industrial alchemy. You start with something super simple, brine, which is just salt water. You pass electricity through it, and out the other side, you get 3 completely new and incredibly useful chemicals.
And here's what they are. From plain old salt water, we get sodium hydroxide, a powerful base for making soap and paper. We get chlorine gas, which is essential for treating our drinking water. And we get hydrogen gas, which can be used as a clean fuel and is crucial for making the fertilizers that feed billions of people.
It's just amazing how this fundamental push and pull between acids and bases shapes our entire world. Think about it, even something like a medical cast. That white plaster of Paris hardens because of a chemical reaction with water. It really makes you wonder, right? What other hidden chemical balancing acts are happening all around you every single day, right under your nose?